Hello students, welcome to my channel. In this class I am going to teach you partial differential equations of a second and a higher order. This is my 8th class on partial differential equation. Now a definition. The linear partial differential equations with a constant coefficient c is defined by f of dd dash into z is equal to f of xy, where d stands for del by del x, d dash stands for del by del y. So now, in order to find the solution of this type of differential equation which is homogeneous, this is a rule we can apply. If ARD plus BRD dash plus CR is a factor of f of dd dash and a phi r of eta is an arbitrary function of the single variable eta, and if AR not is equal to 0, then UR is equal to e to the power minus CR by RX, CR by AR into X, phi r of BRX minus ARY. So here is a question and we have to solve this question. The question is solve d square minus d dash square z is equal to 0. This implies d plus d dash into d minus d dash into z is equal to 0. Now d plus d dash is a factor of the given equation. Here d minus d dash is also a factor. Let us consider d plus d dash. We have d plus d dash is equal to a1 d plus b1 d dash plus c1. Taking r is equal to 1. Comparing both sides, we get a1 is equal to 1, b1 is equal to 1, c1 is equal to 0. Then the solution u1 is equal to e to the power minus c1 by a1 into x. Here putting r is equal to 1. This will be phi 1 of b1x minus a1y. Now putting the values of a1, b1, c1, we get e to the power 0 phi 1 of x minus y, which is equal to phi 1 of x minus y. Again, d minus d dash is also a factor of the given equation. So we have d minus d dash is equal to a to d, b to d dash, c. Comparing both sides, we get a2 is equal to 1, b2 is equal to minus 1, c2 is equal to 0. Then u2 is equal to e to the power minus a2 by c2x into b2x minus a1y. Now putting the values of a2, b2, c2, we get this is phi 2 dash of this. This is equal to e to the power 0 phi 2 bar of minus x minus y. So this we can write is equal to phi 2 bar of minus x minus y, which can be written as phi 2 of x plus y. So we get the first solution is phi 1 of x minus y. The second is phi 2 of x plus y. Then the required general solution is z is equal to phi 1 of x minus y, phi 2 of x plus y. So the required general solution z is phi 1 of x minus y, phi 2 of x plus y, where phi 1 and phi 2 are arbitrary functions. So for the question d square minus d dash square into z is equal to 0, the general solution is given by z is equal to phi 1 of x minus y plus phi 2 of x plus y. The general solution is given by z is equal to phi 1 of x plus x minus y plus phi 2 of x plus y, where phi 1 and phi 2 are arbitrary functions. So with this, the topic for today class is completed. I shall meet you with a new topic in my next class. Till then, goodbye.